7th graders, I am putting out a Chapter 6 test review video. So this is going to be to help us review for Chapter 6. And you have a printout for the study guide, I hope. So we're going to give it a try and just kind of go through some things to be ready for your test. So we're just going to go through classifying special angle pairs. Well, complementary angles, remember, are angles that add up to 90 degrees. So they form a right triangle. So none of these on this picture do, but it's going to be when they form something, looks like a right angle. So if you're asked, this angle is 45, and this angle is x, well, you know that 45 plus x is going to equal 90. So then you subtract 45, and you get that x equals 45 degrees. So those are complementary. Their sum is 90. Supplementary on the same end. Remember, supplementary, Glenn, it looks like an 8. These add up to, their sum is 180 degrees. On the image here, some examples of supplementary angles would be 1 and 2, 5 and 6, 7 and 8, 4 and 3 and 4, just like 1 and 3, 2 and 4, 5 and 7, 8 and 6. So they're the ones that add to 180 degrees. So some examples maybe you want to put on here, you maybe still want the sum is 180 degrees, but then you could write some examples down as well. Angles 1 and angle 2, etc. Alternate interior angles, alternate meaning opposite sides of the transversal. In this case, this is our transversal here, line C. So they're going to be on opposite sides, and they're going to be on the inside. So this is like inside, so opposite inside of our parallel lines. So we look, this is the inside. So you look for alternate interior. So 2 is on the inside. Opposite of it is 7. So examples of angle 2 and angle 7, as well as angle 4 and angle 5. It's a bit messy, but on your sheet you can kind of look at however you need. Just the opposite, alternate meaning opposite, exterior meaning outside. So we have the outside this direction and this direction from the 2 parallel lines. So it looks like angle 1 is on the outside. On the opposite side of this transversal line is 8. So angle 1 and angle 8 are alternate exterior, just like angle 3 and angle 6 are alternate exterior. Corresponding angles are angles that are, I'm going to clean this up, are angles that are in the same place according to the transversal. So if you were to look at this image and kind of cut this into 2 parts, whereas this line was cut by the transversal and this line was cut by a transversal, you kind of look at them as 2 separate parts. So you see angle 1 is in the top left, angle 5 is also in the top left. So angle 1 and angle 5 correspond. Angle 3 and angle 7 correspond. And so on and so forth. Lastly, vertical angles. Vertical angles are opposite of each other on 2 intersecting lines. So line A and line C are intersecting here, making 1 and 4 vertical angles. Vertical angles are congruent. All of these have those congruent pieces to it. Okay? That's in your book as well. All right, finding missing measurement. So on your study guide, I filled in that this was X and this was 110. These were estimates, of course. So what I noticed is that this angle and this angle are vertical angles. And what I know about vertical angles is that they're congruent. So if this is 110, then X is also 110 because they're vertical angles. Here, this was a 90-degree angle, meaning that they add up to 90 degrees. whereas this measure was 10 degrees, and we're looking for here. So it means that 10 plus x equals 90. So you subtract 10 for x equals 80 degrees. So again, knowing the relationship and being able to use that. Drawing some arrows at the end of these lines. So again, we have 1, 2, 3, 4, 5, and this was 135 degrees, 7, and 8. You were asked on your study guide to find the measure of angle 2 and the measure of angle 4. So we have to look at relationships. The one measure we do know is 135. This is the corresponding part, and since the measure of angle 2 is corresponding to 135, the measure of angle 2 is 135 degrees as well. Then we were asked to find the measure of angle 4. Well, we know this now is 135, and I see that these lines together create a straight line. So they are supplementary. So I know that the measure of angle 4 plus the measure of angle 2 add up to 180. So I don't know the measure of angle 4, but I know the measure of angle 2. So I subtract 135, and I find out that the measure of angle 4 then is 45 degrees. Whoop. Moving on, I can find the sum of the interior angles. So finding the sum is the number of sides minus 2 times 180. A little picture for some of you. The reminder of this is why. The reason, I'll use a pentagon for example, the reason you subtract 2 is because you go from one vertice, there are, and bear with my non-straight lines, there are two less triangles in a shape than there are sides. So there are 3 triangles in a pentagon in a 5-sided figure. The reason we multiply by 180 is because each triangle adds up to 180 degrees. So that's why you end up multiplying 3 times 180 for a pentagon. So if I were going to do, your study guide asked you to find the sum for a heptagon. Heptagon. Get ahead of myself here. Heptagon. So that is a 7-sided figure. So I do the sum is the number of sides, 7, minus 2, for how many triangles there are, times the degree of triangles. And so I get 5 times 180, which is the sum is 900 degrees then for the total. The next one was for a 12gon. So that's a 12-sided figure. So I do the sum is 12 minus 2 times 180, which is just 10 times 180 for a sum of 10800 degrees. Okay? Not too bad. The difference is the sum and finding one interior angle of a regular polygon. Remember, a regular polygon is when all the side lengths, so it's like that pentagon or this heptagon, where all of the sides are the same measure and all of the angles are also the same measure. Okay, so regular. So if we're looking for one, that means it's the whole figure. If all of them add up to a certain amount, the sum, if they're all the same, you just divide, because if that means you divide evenly. So this is where you take the sum, you find the sum of the angles, and then you divide by the number of angles. That's your formula for this one, finding 1. Octagon, which is an 8-sided figure, then you're going to do, well, 8 side minus 2 times 180 is the sum divided by 8. So then on the top, I get 6 times 180 over 8. Well, 6 times 180 is 1,080 over 8. And I divide that by 8 because this is the sum. Now you have to remember this is the sum of the whole figure. And then this, if you divide, that's really 8 angles divided by 8 for one angle, which is 135 degrees. The other one you're looking for was 16, Don. So same type of thing. Find the sum. You can find the sum this way. Minus 2 times 180. Some of you don't like setting it up the other way. So then you're doing the sum is 14 times 180. So the sum is 2,520. But we need to remember to divide by the number of sides, which is 16. Number of angles, really. When we do that, we end up with 157 and a half degrees for one angle of a 16 gon. All right, identify two polygons are congruent. They are congruent if all the sides are the same. So I'm just going to kind of fill in what yours looks like. 45 degrees, 45 degrees, A, this is D, D is 45 degrees, and S kind of, sorry about this, 45 degrees for F, there. We determined that they are congruent because they are the same, everything has a matching corresponding part. So they, yes, they're congruent, and our congruent statement then is the triangle A, B, C is congruent to, now I see that A corresponds, if I were to turn this on its side, corresponds to D. And I see that B, angle E is also the right angle, and then F and C are congruent. So remember, corresponding parts. Finding the missing angle measure. This may not be super accurate on the measurements, but the point is to get the picture. So if we have Y, X, and Z, we have N, M, and L. We're looking for this angle measure here. And you're given these parts. And they told you, I guess this should have had on it, triangle X, Y, Z is congruent to triangle M, L, N. And so if you're looking, it says find the measure of angle L. If you're looking for that, you say, oh, L corresponds with Y. So you look for, well, what is Y? Looks like I don't know that either. But I do know a triangle has 180 degrees. So that's 180 minus these totals of 120 for a total of 60 as well. So if angle Y is 60 degrees, then angle L. So this is just kind of an inferring question. Again, the measurements may be off if you were actually, but the point is to get the idea of looking for correspondence first. On the back, you have some points plotted. Let me get these on there first. This one we're supposed to reflect on the x-axis of the points A. I kind of have to guide myself here. I think C is about here. And B on your sheet is about here. So we're reflecting on the x-axis, which means I would highlight where I'm crossing the x-axis, and I'm going to go from there. So, looks like I go, A is 2 away, so it's going to be 2 away here, and I label it A prime. B is 1, 2, 3, 4, 5, 6 down, little different. Go by yours. If you have it for your test. C is 4, so we're going to go 4 up. Label it C prime. And we should have a reflected figure over the x-axis. Mine looks a little stretched out. Okay, and then the next one was over the y-axis. So you're going to flip over this line. That original shape again. Get it right. A, B, and C. Here's already drawn for you, so flipping over the y-axis, so 2 this way, I mean 7 this way, so we go 1, 2, 3, 4, 5, 6, 7, and 1 in. Notice I labeled them prime. That's going to be a really important part tomorrow. Flip it over on that axis. Hopefully it looks a little neater on yours. My smartboard's been acting up lately. And then translating. And it said translating, which is x plus 3, which means 3 to the right, and y minus 4, which means 4 down. From our original figure, which was, looks like z is at -2, 5. Smartboard's a little off. And z is at 8, 9, y. And then w. Down here, I think. Bear with me. All right, my phone is ringing, so let me pause. And we're back. No one was there. And connecting. Again, if mine's a little off, go by yours. Same thing though. So that means if we're going to translate, that means we're going to move x, the value. You need to know these. If you have a graph, say you know the coordinates, it's asking for x prime. Well, your coordinates for x are 1, 2, 3, 4, 5, 6, -7, +7. So it's -7, 7. So you do -7 plus 3, and then 7 minus 4. So x prime would be -4, 3 is your new one. So you go -4 up 3 would be your new translation of x. Okay, so you do that to find 1. If you had to move all of them, then you do the same thing. So you go 3 to the right, 4 down for w prime. You do 3 to the right, 4 down, c prime. 3 to the right, 4 down, and you'd have your figure. Okay, so hopefully this was a very quick review, but hopefully it was helpful review to get things in check.